Okay, alright, we're good. Okay, hello everyone. Welcome back for another exciting week in game making. Today we're not working in Scratch. Today we're going to be working in WoofJS, which is our own little thing for teaching transitioning to JavaScript from Scratch. So let's get started. Basically, it's for those of you who are, in the know. It's just a JavaScript library that encapsulates all of the Scratch functions using similar vocabulary and syntax to sort of make the transition a little easier. So let's get started. We're going to make a visual novel. A visual novel is usually like narrative, lots of pictures, different choices, simple mechanics usually. They're fairly popular actually, just because they require sort of less intense mathematics and mechanics. But let's get started. Alright, so this is the default WoofJS screen. We got all of our tutorials, which we aren't going to go through today because we're making a visual novel. We got some documentation here, which maybe will be relevant as we go. Alright, but the first thing I want to do is assemble a chat system like I had in Scratch with the sprites that talk, and you can set sprites to talk. So let's work on that. First thing we're going to do is we're going to upload our sprites. So let's jump over to sprites and background, images, upload image. And my copy of the images are currently stored in okay. Who should we grab today? Let's grab. Dude. Only one at a time. How sad. Sorry, I'm just looking for the idle one. Okay. Oh, right. We have to log in. My mistake. Log in. Okay. Okay. Save. Okay. We also have to save our project first. Visual novel. All right. Third time's the charm. Let's do it. Did it go? Happiness? Happiness? Where is it? It doesn't always put it at the top, which I think would be a great feature, but it's not always at the top. Where are you? Where are you? Oh, okay. Did it work? Oops. Where are you? Good. Okay, there's that one. It didn't upload the one I chose though. We'll go ahead and grab this one too. Okay. We'll just start this one because it worked for some reason. I don't know why that first attempt didn't work. Okay, but let's plop him down over here. And I'm just going to rearrange how this is written for legibility reasons. Okay, first thing I want you to notice is that there is a property of the image called URL. And there's also other properties which will, for example, X is 50, Y is 50. And that moves him over. Like, I can do this for more if I wanted. Yeah, now he's off screen. 200. Yeah, now he's up there. Okay. But there are properties, and we can set them also outside of the constructor. Constructor is what we call this thing. It constructs a new image. But we can also set them out here. We can do sprite1 dot x becomes equal to 200. And that's going to move him over to the right. See, there he goes. And as it's relevant now, we can also change the URL. And we're going to use this to change the URL of the sprite to different image files. And that's how we're going to control the costumes mechanic that we used in Scratch. So, our next step is get all of our files uploaded. So what is that one? Is it just, I think that's, I already have that one. Or at least the ones that are relevant. We'll just upload a couple, and then as we need them, we'll upload more. And what I'm going to do is I'm going to create, let's name our character. What should we name him? Let's go with Percy. Percy. We're going to create a map. This is another constructor. It's the exact same thing as this. Except instead of creating an image, we're creating what's called a map. Which map just means that there are named pairs of values. For example, Percy.cat equals lemon. And we can create new named pairs just like this. So now if we like alert Percy.cat, it's going to say lemon. Lemon! I think you can all see that. Can you all see that? Okay. I'll avoid things like that in the future so that we don't lose consistency. Oh, why are you... Alright. But anyway, I'm creating this Percy. We're going to say Percy.idle becomes equal to this string here. And then we're going to say our constructor URL is instead going to be Percy.idle. Also, just because there are sometimes issues that can occur with auto-run, like you can end up in a infinite loop, that sort of thing, I'm going to turn it off so that it only actually runs code when I tell it to. But anyway, so now we're going to do Percy.jump, which is this string here. And so on. So we can create all the different frames that we care about. Percy.thumbs up. Let me upload that one. What? Why are there... There it is. Okay. And let's do Percy.talk. Where is... Here it is. Here it is. Okay, so now we have 4 different frames that we can switch between. And for the, I want to make them a little bigger. Width and height are also things we can set. 200, height 200. And let's run that. Oh, all right, he's not. He should be flatter than that. Something like that. Okay. For those of you who have played my other games, you'll notice that there's a distinct difference in how this character looks. Why? What the? So, like, for example, let me sign into Scratch real quick, so I can kind of show you what I'm talking about. I'll show you both for points of reference. Okay. So you notice that this character and this character are approximately the same size. And they're the exact same resolution, because they're coming from files of the exact same size. But this one looks very clear. It's got clear edges. But this one does not. This is because it is anti-aliasing. So the actual image of this of Percy here is like 23 pixels by, I think it's 47 pixels. And the screen, the monitor resolution that we're looking at here is obviously much higher. It's something like, 1900 pixels. So when we blow it up and when we make the Percy picture bigger, the monitor has to decide how to determine which pixels should be, like in his hair's case, brown, and which pixels should be blue for the space behind him. And in this case, what it's doing is it's averaging. It's saying, oh, it's saying like this hair pixel here, and this one pixel is brown, and the pixel next to it should be like an average between the brown and the blue to sort of create a transition. And then the pixel after that should be blue. So it's creating like a smooth transition into the different colors. And this obviously makes things look blurry. It's useful for things that are a higher resolution than your monitor. For example, if Percy here were 10,000 pixels and my monitor were only 1900, then the averaging process would work in reverse and it would actually look probably better than otherwise. But as is, we've got sort of a problem here that we're going to have to address. We're not going to address it today, though, because I need to do research for it. That's not very interesting to watch on screen. So we'll do that on another time, on another instance. Well, by the way, anyone who's watching, we just finished our Coding for Challenge finale. Congratulations to the winners. Yes, I have a bell. I have a new bell. It's going to be very annoying for all viewers and students that I teach. Ha. Anyway, for now, just try to suspend your disbelief at Percy's, his, murkiness. And I'll see about migrating him to a clearer picture later on. Okay, so here's Percy. And just for the sake of example, I'm going to actually rename his sprite real quick to Percy. Percy.url becomes equal to Percy.talk. I can run that? Why is it not changing? Percy.url. Do we have a conflict? Percy img. Did I copy the wrong sprite ever? Oh my gosh. Is it the right URL? Did I miscopy it? What's going on? I mean, they all have unique endings. Yeah, what's going on? Percy.jump. It's not changing. What's going on? I don't know. This is interesting. Set interval. Why am I doing everything in caps? It's the timeout second. Okay. Function. Sorry, I'm just doing a test. My thought process was to determine if this is a refresh issue where the screen just isn't updating, or determine if there's an actual sort of mechanical issue here. And I'm saying I wanted to run this code every thousand milliseconds or every 1 second. So yeah, let me see what this does. Interesting. Let's look at the image documentation here. Is there any image documentation? Maybe updating. This is somewhat embarrassing. I did not know that images did not support being updated like this. Oh, okay. They use a specific function. Set image URL. Alright, let's try this. There we go. That's a terrible refresh time, but yeah. Alright, we got it. And, okay. So while we're here, let's just see if we can't kind of put this in perspective. Let's do math.random times 4 math.floor. You might be wondering what I'm doing here. I mean, I'm calculating a number between 0 and 3, basically. 0, 1, 2, or 3. Math.random returns a number between 0 and 1. So it's like a advanced decimal between 0 and 1. Times 4, which should essentially make it run from 0 to 4. And then floor rounds it down. So we're going to get 0 through 3 and exactly on the integer. All right. And the reason this works is because well, actually it doesn't work. No, we're going to have to do it like this. All right, Percy object.keys Percy. What do we want to do here? All I want to do is make it change to a random sprite, but maybe that's like more effort than we really want to do. Let's just keep moving on and get to our chat system. So, okay, so we need a forever loop. Forever. This is representing the forever block in Scratch. What it does, it's going to do whatever it marks in here indefinitely. And however, differently than Scratch, this is asynchronous, so it's actually going to start the forever loop and it's going to continue on and doing code after it. It's actually sort of like a very confusing aspect to WoofJS that never seems to come across quite so clearly to our students, and we're working on that. But let's basically copy paste the code from Scratch, which was forever if we'll call it Percy. Well, I think we can change this back to Percy. I'll change this one to Percy sprites. Percy.talkState equals talking. And in here we're going to add one more, Percy, or is it talkState not talking. This is just, like, these don't have any coding implications in and of themselves. We're going to write the code that makes them have a function. So if Percy's talkState is talking, then we set we have a variable that's like Percy last costume. We'll call it last sprite. We should move to the sprite verbiage. Last sprite should also be Percy sprites.idle to start with. And this is just going to track the last sprite that Percy was currently on. Okay. Then last sprite, then Percy dot last sprite becomes equal to Percy dot URL. So we store the current sprite inside of a last sprite variable, and then we repeat until, in this case, not mouse down, but repeat until, what was it? Percy.talkState is not equal to talking. And I can compare this to Scratch to show you this as more or less a one-to-one conversion. Forever, if talkState is equal to talking, set last costume to costume, repeat until not talking, blah 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 blah. Yeah, so it's basically one-to-one. All right, and then we want to Percy.set image URL to Percy.talk. So we want to look to see how to do waits in this. Does it want me to do set timeouts? After. Okay, after. It uses afters. So after math.random times what was our range in the other one? 0.1 to 0.3. So times 0.2 plus 0.1. That gives us 0.1 to 0.3. So after that amount of seconds, we want to Percy.set image URL to Percy.last sprite. And then after the exact same amount of time, we want to Percy dot. Wait, is that it? Is that all we need? Talk. We just wait after that. I know what it is. I think we have to put the weights first. So in JavaScript, these afters are not going to be run synchronously. Like it's going to keep going after. So like in Scratch, our last step is to wait. But if we do this in Woof, it'll just create a separate sort of logical thread that's waiting on its own while the main loop comes back to the top and starts over again. So instead, we're going to have to put the waits first so that they can include the code to run after they've waited. Functionally, it shouldn't be terribly different. It just means that there will be a short gap before the lips start moving. Oops. This formatting style. Oh my gosh. Is that right? I think that's right. Okay. Okay, I think that's good. So now, instead of doing this, we can set talk state to talking. All right, so this is basically going to we're going to actually Percy.talkState. Yeah. Let's just try it. Percy. Oh. Yeah, I'm gonna fix that in a couple places. Percy sprites, Percy sprites, Percy sprites, Percy sprites, Percy sprites. This should be Percy sprites. What? Image URL is misspelled. Oh. Wait, no. Okay, there's the talk sprite. This is misspelled? Oh, we don't need this backdrop anyway. Ugh. image URL is undefined or not correct. Okay. I assume that issue is here. I'm going to alert Percy.url. Right, yeah, it's undefined. Alright, instead, I'm going to alert Percy so I can take a look at, okay, that's an object. So the way that this image code here has been written is that image is like an object with things inside of it, including some other object that has a URL property. I'm just trying to find the accessor for it. Okay, type project angle rotations showing pen down pen blah 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 blah. 2 JSON. That's awesome. Render collider, move set, radians, canvas, point towards, on mass handler, image height, image is what we're looking for. Okay, I believe it's Percy.image. But we'll try that. Okay. So that's an HTML element. .src. Yes, that's what we need. Okay. So instead of Percy.url, we just have to run this instead, because it's actually a more complicated object than its constructor makes it seem. What's wrong, buddy? Oh, okay. Wait, no? No? Okay. This is gonna be... this is gonna be challenging. Okay, so what's happening here? We're gonna have to redo this whole structure. So like I said, these repeat untils, these forevers, these afters, they are all asynchronous, which means that they more or less think of them as like breaking apart a separate strand of time that runs independently of everything nearby. So basically, while this chunk of code is running, this repeat until is still with independently of this after. And likewise, this repeat until is running independently of this forever. So essentially, while this repeat until is doing all of these afters, this forever is cycling through, checking to see if our talk state is talking, and then queuing up an additional repeat until. So we've got like, 10, 15 repeat untils running at the same time. And when, repeat until X, number 3 or whatever goes to check the last sprite, it's still set to talking. So they all end up converging on this talking sprite. Alright, so here's our first major engineering challenge of this. We got to figure out a way to make this work without afters, actually. Without afters. Let's add another state called start talking. And then when that becomes activated, let's set Percy dot talk state to talking. And then we want to repeat until talk state is not equal to talking. And at this final lap here, I think this is still going to have some bugs, but we can do Percy dot talk. Yeah, this is still going to have some bugs, but it will be improved. Finish talking. This isn't even accurate. This assumes that he's going to be finished talking after a single loop, which isn't true. But let's see what kind of behavior we get. Yes. Yeah. And the reason it's doing that is because I fixed the bug with the top level forever if, but now we've got the same bug with the repeat until. Maybe it's best we just find a different structure for this entirely. See, JavaScript does not like to wait. Does not like to just sit still and do nothing. Let's do a recursive function instead of a forever. Okay, so let's try this again. Alright, I'm gonna reuse all of this. I'm gonna move this here just for reference, but write a function called talk. It's going to take milliseconds. This is going to call talk for 1 second or something. How do we want to do this? We've got to use deltas. This is getting way too complicated for a WoofJS level. Do we even have any reference on deltas? Huh. Does anyone have any ideas from chat? Yeah, I mean, game making, like, proper games, or not proper games, like, obviously this would be a proper game, but like most games would use a delta structure to do this. Delta structure means tracking how much time has passed instead of doing like waiting like you would in Scratch. You would say like right now is 6:40. At 6:41 do this. Instead of waiting, you just schedule, say when to do things. And you can do this like you obviously don't have to specify a point in time. You can do this relatively, saying like I just did this at plus 7 seconds do this. But that's using like a Delta framework, which is above and beyond what we usually teach for Woof. Maybe we'll do a visual novel in Scratch instead. Is that all right with everyone? Let's switch. I've already got everything set up here because I made a template for doing a visual novel in Scratch. So we'll just work with this. Yeah, we got it. Yeah. Welcome to the stream, everyone. We're gonna make a visual novel in Scratch today. I hope you're all excited about that, and definitely don't remember the last few minutes. All right, so I took the liberty of making a template from last time's talking system, and I just copied it over here. So this is exactly the same as it was last time. I can do whatever I'd want to do. Let's just to refresh everyone how it works. Let me record a sound. Hey, I'm Trek. What's your name? Oh, I need to click record. Hello, I'm Trek, and this is Mina. Hello, I'm Trek, and this is Mina. Okay, cut. Good, save, whatever. Recording 1 is fine. All right, so say hello. My name is Trek, and this is Mina. Give it a go. Hello, I'm Trek, and this is Mina. Oh, the old talk state was... Wait, no, it wasn't. What's going on here? Why is she stuck in... Hello, I'm Trek, and this is Mina. Hello, I'm Trek, and this is Mina. Cool. All right, everyone knows what we're doing. Okay, visual novel. So we need to have a dialogue system in which people can choose different dialogue choices. I want to use buttons. I don't want to use the ask controls. I think buttons are just a little bit more user-friendly. So let's keep it simple and just do yes or no questions. So I'm going to make 2 sprites for buttons. I'm going to have them appear at different points in the game for, yes, no question answers. Okay, so let's make a button. Alright, purple. Yes. I'm going to zoom in. Alright, let's do green. Let's lower our outline just a bit. Text. Yes. Change our color to black. Cool. Alright. There is our yes button. Then let's duplicate that sprite. Change the text to no. Move it over slightly. And change the color to red. Maybe a little more intense red. Cool. Alright, we have a yes and we have a no button. Let's call them respectively yes and no. Alright, and we're going to reuse these buttons throughout. So we want to kind of set them up in such a way that they can be reused. We're going to use like an event structure. So we're going to broadcast input received, which just indicates that they've given an answer. And we're also going to broadcast yes when the sprite is clicked. broadcast those two messages. I'm just going to copy this over to no. Instead of yes, we're going to broadcast no. All right. So now anyone can listen to these two buttons and perform logic based on what they need to know. I'm going to create an empty sprite. Maybe we should just do it in Backdrop, actually. So let's do like we're going to have to like schedule their conversations, you know, like 10 seconds later say this, 10 seconds later say that, unless we use an event system for the people too. So let's kind of set up a, at the end of talk, let's broadcast a finish talking message. Finished talking. And same for this one. Broadcast finished talking. So now the characters know when each other have finished talking. We should probably put just a very small wait there, because usually people don't jump on you right when you finish talking. So let's do like 0.2 seconds. And 0.2 seconds. Unless we want to put that behavior as part of the conversation. Yeah, actually, I think it would be better to be part of the event that handles finish talking, because sometimes you do want to jump right on it. Like when someone says I did it, you want to respond right away. Yeah, I did it. Yeah, you know, there's no pause. But if someone's like, yeah, my mom's name is Brittany, my dad's name is Carl, and you're not like right on the end of the sentence, so let's leave it like that. Okay. So, we can essentially make a dialogue list for each character. Let's make a list. Let's call it lines. And this is going to be basically a text. Forever, forever. Forever. Item 1 of lines, and where's join? Recording, and we need a variable for this spread only. Line index. So this is just going to track which bit of dialogue they're currently on. Item line index of lines, and item join recording plus line index to tell which voice line to play. Actually, do we even need that? It's not. Okay. When I receive, finish talking. And change line index by 1. Okay. So, whenever someone is finished talking, they say their next line. I'm going to add that wait I discussed. This basically means we're going to have to put empty lines. I think this could still end up sounding very natural. Some of them will be empty. Like sometimes people do like while the other person's talking. We can do that sort of thing. I just want to set line index to 0. Okay. I think that's all we need. We just need to copy all of this to our friend. Who just needs his own lists and such, which he apparently has. I just made it for him. No, it didn't make it. I'm confused. Do you have it or not? You do. Oh, I guess it just created it for you. Okay. Let's give our characters a name. Let's call him Carl. Let's call her Jessica. Okay. I need an idea for what these two are going to discuss. What do they want to talk about? Let's just do a simple conversation for now. We can worry about more advanced plot later. Okay, so basically, these two we just need to see their lines list. Hello, Jessica. Okay. So with two people talking at the same time, we're going to be getting finished talking events, essentially twice per line, which might interrupt them to make them talk again. So what we want to do is whenever we receive a finished talking event, we want to repeat until, like, they have to wait until they're not talking in order to say the next line. Because obviously they can't talk while they're talking. In fact, maybe this is just a good place to put that. I think that'll come out very naturally. Okay, I'm going to copy this back to Jessica. So if they receive, other person has finished talking while they're in the middle of a sentence, then it doesn't, interrupt themselves to start saying their next line. Okay, let's record these and just see how it works so far. Hello, Jessica. Hello, Jessica. All right, and on Jessica. Oh, hey. Oh, hey. All right. All right. Take your bets now. What's going to happen when I click play? Oh, I need to have someone start the conversation. Carl's going to talk first. Okay, that just increments. He says the first line by force, and then whatever. Hello, Jessica. Oh, hello, hey. Jessica. That was interesting. Why does it cycle? Hello, Jessica. Oh, hello, hey. Jessica. Why does it do it twice? Like, Carl ends up in an infinite talking state. Move him over a little bit so we can see these lists. Oops. Why does he end up? Hello, Jessica. Oh, hello, hey. Jessica. Oh. Oh. That's just because this talking should be normal, not all caps. Hello, Jessica. Oh, hello, hey. Jessica. All right, let's go. Let's figure this out. So, Carl talks. He says item line 1. Oh, that's because it's 1 indexed. Well, I mean, that might be why. Hello, Jessica. Oh, hey. There we go. Why doesn't she stop talking? Because she doesn't have another line. Okay. So it keeps trying to talk with, in fact, I can prove that. Let's just have her show line index. Hello, Jessica. Hello, Jessica. Why'd you stop? Well, just because I started showing it. She is stuck in the wrong... What is going on? Hello, Jessica. Hello, Jessica. Hello, Jessica. Hello, Jessica. What just... Hello, Jessica. Hello, Jessica. What changed? Wait, can we... Hold on. Yeah, you can definitely play multiple sounds at once. Recording 1. Why? Hello, Jessica. Hello, Jessica. She's getting locked in. Hello, Jessica. What is that? Why is she not able to say her line? Her line index is 1. Hello, Jessica. Line index. What is going on here? Hello, Jessica. She's not even saying anything. Let me turn off your variables. Hello, Jessica. Oh, I know what the problem is. Okay. It's because I'm not resetting their talk state. My bad. Okay. Sure, 0 is fine. Hello, Jessica. Oh, hey. Yeah. So what is wrong with her frames now? I think it's just that. Yeah, it's just that. Now we need to end it when they're out. Okay. So if line index is less than, I have to do a plus. Oops, that's a multiply. Length. Okay. So it only tries to say the line if we're still in the index. So I'm going to duplicate this and send it over. What? Whoa. Whoa, Nelson. Whoa, Nelson. Okay, let's try this. Hello, Jessica. Oh, hey. No, that still didn't work. Hello, Jessica. Oh, hey. There it goes. Okay. Hello, Jessica. Oh, hey. Okay, let's try adding lines. Looks good, looks good. I heard. Alright, let's see how this works. Let me record them. Okay. Recording 2. Is it I heard you like playing, or I heard you... I can't read it. I heard you can. Okay. I heard you can play the saxophone. Is it true? Her sign. Yes! Da, 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 da. We're coming up with like the world's most advanced conversation system. I love playing music, yes. I love playing music. Alright, let's give it a try. Hello, Jessica. Oh, hey. You can play the saxophone. I love playing music. Yeah, so they're responding to themselves, which is what I was trying to avoid with this finish talking thing. I think we should do the finish talking event first. Maybe. I love playing music. We just don't want them to respond to themselves is the goal here. I guess we could just do specific events for the two characters. That's probably the easiest way. There's not really a way to check to see who broadcast the event. Okay, let's try this. Hello, Jessica. Oh, hey. I heard you can play the saxophone. Yes. Is it true? I love playing music. Now it sounds way too back and forth. Like, we want it to... Like, I would like Jessica to say yes at around the same time as Carl says, "Is it true?" Which would imply that Carl would say, "Is it true?" immediately after he says, "I heard you play the saxophone." Which means he is responding to himself. but Jessica is not. We can model it like Carl is conversation lead. Since you're leading the conversation, you're you're introducing your own discussion topics, and thus you aren't waiting for the other person. So like we can like add some metadata to the lines that's like take lead or give lead sort of thing. And while a character has lead, then they can respond to their own dialogue. And while they don't have lead, they wait for the other person. Yeah, let's try it. Let's just see how it works. So let's make variables. This will be a global variable because there's only going to be one lead in the whole conversation here, regardless of how many characters there are. So just call it lead. I don't know why I'm using all caps. It's because I've been writing a lot of JavaScript constants recently. Okay. But then we need metadata about the lines. So I guess we need a second list. That's line actions. Line actions. Change all these back to finish talking. And we're going to determine who has the conversation lead, and we'll operate off of that instead. So line actions, none, and take lead. Okay. And then Carl's line actions. Am I doing it all caps? No. Is take lead. The rod. None. None. Is that how we want to do it? I feel like if you ask someone, no, is it true is definitely giving up the lead based off of our model. Okay, let's try this. So whenever you talk, repeat until you're not talking, or you are the lead. Okay, yeah. I believe that's how this works. Repeat until you're not talking, or lead equals Carl. Alright. And then whenever we talk, oh, not like that, yeah. if line index, oops, equals lead set lead to Carl. Isn't it amazing just how complicated modeling a conversation is? Okay, so this is like this. Let's copy this over to Jessica and get rid of the old version, and then replace the instances of Carl with Jessica. Oh, actually, I can get a sprite name, can't I? I cannot. Sensing maybe? Can you get a sprite name? Can you really not get sprite name? I guess you can't get sprite name. Okay. Okay, let's try this. Hello, Jessica. Oh, hey. Yes, I love play the saxophone. Hello, Jessica. Oh, hey. Yes, I love play the saxophone.